All right, and we're back. We're near the end of class now. All right, you guys, we're using those turntables. Or I should have shown you guys. You guys got a protractor, a stopwatch, a ruler. The mouse was stamped on that, if that matters. I did also give you guys those speed gates, which there's an alternate way to get that going through linear velocity, right? So you didn't have to use that. All right, you guys got AP style right up. Let's score this thing. All right, so wait, actually, before we score it, here, I'll show you guys the poster version. Because guys, here's the answer right here. This is the poster answer. The answer's right here. Okay? So here's the free body diagram on your coin going around. Okay? See, there's some angular velocity, like turns per time. Maybe you could quantify that in radians per second. That's that omega. Okay? Now, at some point, this would break friction and slide off. Right? So there's like the maximum friction. So you can solve for a coefficient of static friction because it's like the maximum value. Right? So weight down, normal force up, friction in. The faster the spins, the more the friction force gets bigger, 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 right? Until at some point it breaks, flies off. So the friction force is acting as the centripetal force. Well, guys, what's the formula you guys know for friction force? What times what? Coefficient of friction times normal force. Yeah, and the normal force is equal to the weight. That's got substituted in the next step. Okay, so you have a coefficient that you can solve for. That's the goal of the lab. Can you solve for that character right there? Guys, what's a formula you know for a centripetal force that also involves angular acceleration? How does that go? M omega squared times r. Does that look like the O'Neill cylinder formula? You guys remember O'Neill cylinder? You guys remember that, right? Right here, this it's hanging up right. Well, do I have it here? I'm gonna find it real fast. O'Neill cylinder. Where are you? Right here. Aha, O'Neill cylinder. Point right there. Right. Right. Now I have an inequality because remember the friction is building up to that point, but you could just call this equals if it's like at the point that it breaks off, right? There's some angular velocity it spins at the point. So next step, I just substituted normal force with weight because they're equal to each other here. You got that? Ooh, hey, the math cancels out. Maybe it'd be good practice to record what the math is anyway. That didn't matter because it cancels out whatever lab math you were using. Okay? And then you could solve for this coefficient of friction. And this is the answer right here. Just change this inequality to equals. And you got how fast is it rotating in radians per second. Square that. Multiply by its radial distance from the center, say in meters. And divide by a gravity field, you could use 9.8 meters per second squared. Okay. Or if you put it in centimeters for R, you could use 980 centimeters per second squared for G, and you could still get the correct answer. Okay. Okay. So there's the poster version. Let's show you guys the write-up. All right, you guys ready to get the write-up? There we go. Oh, so part one, question. What is the coefficient of static friction between the lab weight and the surface of the turntable? Everybody's got the question, right? What's the coefficient of friction between those two surfaces? That's all. Right. Measuring tools. You can do this entire lab with these two measuring tools, the ruler and a stopwatch. That's it, ruler and a stopwatch. Right? And if you also included a scale to keep track of the mouse or something, that's okay too. But you definitely need a ruler and a stopwatch. And remember I was telling you guys this box is the answer? The ruler, you can, oh, nope. I'm an idiot. Wow. I missed something. Guys, what measuring tool did I obviously miss? Protractor. Well, unless you counted revolution, maybe it'd be okay to count revolutions and convert to radians, right? So anyway, if you put a protractor on there, that might be a good idea too, right? But you do need, yeah, definitely a ruler for this R, a stopwatch so you can measure. You need to be able to calculate how fast is it rotating. That's this omega right here, right? You could do revolutions per second, and then maybe you don't even need the protractor necessarily, right? But you need to convert to radians per second. That's it. All right, setup. Place a weight of known mass on this horizontal surface of a turntable. There you go. That's the entire setup. It's all encapsulated in that one sentence. Just set a lab weight on a horizontal turntable. That's it. Okay. Step two, use a ruler to measure the radial distance of the lab weight from the axis of rotation. Boom. Okay. This point for using the ruler. Step three, speed up the rotation of the turntable. A little faster, until the lab weight breaks friction and slides off. Okay. Because that point, the static friction is maxed out. And because static friction is maxed out, now there's a way that you can determine the coefficient of static friction. Okay. So you want to speed up the turntable until the slides off. Okay. Next step, maintaining the angular velocity of the turntable at that moment, right? Because however fast it was spinning, you want to maintain that angular velocity. Use the stopwatch to measure the time for 5 revolutions, possibly. It doesn't have to be 5 revolutions. I just did an example, right? Could be 3 revolutions, could be 1 revolution, could be 10 revolutions, right? I said, measure how much time for so many revolutions, right? Now, guys, in your math, you're going to have to convert revolutions to what? Radians. And what's that conversion? Suppose that was 1 revolution. How many radians is that? 2 pi, right? Just how many revolutions, just multiply by 2 pi. So in my case, it would be 5 times 2 pi. That'd be how many radians did it turn? Okay. Multiple trials. Hey, repeat 3 times and record the average value in order to reduce experimental error. That's always the point on the AP exam, right? Multiple trials. Right? And then last step here, maybe this is more of an analysis type step, is how to get the angular, sorry, never mind. Right. Determine angular velocity. So how do you figure out how fast it's rotating? I got 2 pi times the number of revolutions. So there's the number of radians. There's the angular displacement in radians right there. Right? Divided by the time to do that gives you how many radians per second. True? Right. So hopefully one of your columns is how many radians per second. Right, let's get that. Right. Analysis. Now, if I did tell you guys while the recording wasn't going, you don't necessarily need an independent variable for this particular lab. Right? Maybe you could change the radius. You just should still get the same coefficient of friction, right? But this is one of those labs where you're just solving for a particular thing. Right? So notice I don't have any graphs necessarily. Right? My analysis is just the equations, and the analysis is just this right here. It's the same as this poster. Right? It's the same as this poster right here. Actually, I did 2 versions of this. So I did, they both start out the same way. Centripetal force is provided by the friction force. Okay? But then the next step I did a little different. So on the left side, I got m omega squared times r equals coefficient of friction times normal force, which is exactly what this poster shows. It's all in terms of angular velocity. You go down to the end, you get coefficient of friction is equal to omega squared r divided by g. Exactly what this poster shows. Omega squared r divided by g. Okay. Now, I did pass out for you guys those speed gates. So you could have the masses flying through the speed gates. That would give you a linear velocity. So you could do it the other way. You could do centripetal forces mv squared divided by r, and then substitute. So you could get it that way too. Finish it that way. All right. So conclusion: coefficient of friction is equal to some number. And guys, what units did you attach to that number? Aha, no units, right? Or you could say Newton per Newton, or just leave, don't put it any units, right? This is one of the few times in physics where you get a number with no units attached to it, because coefficient of friction is just a ratio of 2 forces. So the Newtons cancel out. All right. We got that? Okay. All right. One last thing here. Here's my version of this lab table. If I went back and amended this, I might make an extra. Well, here, there might be slightly different ways to do it. All right, let me hang this up here.